And on 3C.11, we're going to learn about additional trig functions. Yay! All right. So if on your test yesterday, your mock exam, you saw SEC or CSC or COT, we're going to learn what those meant and how do they come to play. All right. So more functions. Just when you thought it was all over and you knew all you could know about trig, ha 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 ha. There's more, but don't worry, it's nothing harder. All it is that a build on of your sine, cosine, and tangent. So they're all connected. So what these are called our reciprocal functions. Okay, your reciprocal functions, just like anytime you reciprocate a fraction, that means you're flipping it, right? So these are the reciprocal functions of cosine, sine, and tangent. So when you see secant, if I can write, my gosh, nothing wants. I said, oh my gosh. I said, oh my gosh. I just want to write. There we go. When you see secant, it means 1 over cosine x. Okay. That is what secant is. Secant means 1 over cosine x. When you see cosecant, cosecant means 1 over sine x. When you see cotangent, cotangent means 1 over tan x, or it could be cosine over sine. Okay. So tying this to what we already know, bless you. So in terms of a unit circle, your secant x, it equals your, instead of cosine being x over r, secant is r over x. In terms of your unit circle, sine is y over r, right? Sine is y over r on the unit circle. So therefore, cosecant is going to be r over y. Okay. And then cotangent, in terms of our unit circle, tangent is y over x normally, right? When I reciprocate that, that's cotangent. And that makes it x over y. So if I ask you for the secant or the cosecant of any value on the unit circle, all you're doing is reciprocating what you would normally do to find it, which means flipping the numerator and the denominator, correct? All right. So now what we've learned about rational functions is that what can your denominator not equal? In rational functions, your denominator can't equal 0, okay? Because your denominator can't equal 0, you now have vertical asymptotes. Just like any other rational function, if you have a 0 in the denominator, that creates a vertical asymptote, correct? So because each one of these has a value in the denominator, that means they all have vertical asymptotes, okay? They all have vertical asymptote because at certain values, you're going to get 0 in the denominator, right? So thinking of on our unit circle, right? So on the unit circle, when does x equal 0? When does x equal 0? At 90 and 270. At pi over 2 and at 3 pi over 2, you're going to get a 0, right? So that means that our asymptotes for this one are going to be at pi over 2 and 3 pi over 2 and all of their coterminal angles. Does that make sense? Cosecant. Cosecant is 1 over sine x, so y's in the denominator. On our unit circle, when does y equal 0? There you go, at pi and 0. So at all coterminal values of 0 and pi, or 0 and 180, you're going to have a vertical asymptote, okay? Those vertical asymptotes are going to be the same for cotangent because that's when y's in the denominator, okay? So now let's take a look at their graphs. So up first is our secant graph. So for secant, remember how we said that at pi over 2 and at 3 pi over 2, there's going to be vertical asymptotes and at all of their coterminal angles. So it's a it's going to be repeated vertical asymptotes, okay? So because they are repeated vertical asymptotes, we write it as a rule. And the rule is you have vertical asymptotes at x equals pi over 2 plus pi times k. Okay. When we talked about cosecant, we said that we have vertical asymptotes at 0 and 180, right? So at 0 and 180, so its vertical asymptotes happen at all of our pi's. So we write the vertical asymptote rule as x equals pi over k. So essentially, how do you create a cosine and secant graph? If you look right here, it's basically the graphs, right? So do you see your cosecant? I mean, your cosine? Do you see your cosine graph? So it's your cosine graph created. And then on the curves of your max, where your max and mins are, that's where your secant begins. So where you have a max, secant has a min. Where you have a min, secant has a max. Do we see that? And that's why we have these kind of sketched in there to remind you. All right, and then cosecant is based off of the sine wave, right? So we see the sine wave, and it follows the same rule of where I have a max on my sine wave, I'm going to have a min as a cosecant. Where I have a min on my sine wave, I'm going to have a max for my cosecant. All right. And that's how you, another way for you to remember that they are who they are reciprocals of. Okay. I know in your brain you want to think S with S and C with C. Nope. It's the opposite. Everyone, you're not paired up. Okay. Lastly is our ranges. So obviously our domain isn't infinite because we have vertical asymptotes, right? So our domain has asymptotes that prevent it, and our range only goes from -1, negative infinity to -1, union 1 to infinity. And I don't know what happened to my parentheses in the middle. Don't know where they are. But let's try this again. So these should be, there should be a parenthesis here, block here, block here. I don't know where they are. Are they on your paper? They just, they didn't want to be there for today's lesson. Yep. Okay. And so in between -1 and 1 is never utilized. Make sense? All right. Questions, comments, concerns. Let's talk about tangent. So tangent's reciprocal is cotangent. So as you can see here for our cotangent, again, it's going to have the same restrictions as our cosecant. And that's when no one wants a black highlighter. So it's the same as sine. So it's when your x equals pi k. Those are where your asymptotes are going to reside. Okay, a big difference between tangent and cotangent. Remember, tangent, we were increasing. Y'all remember that? Tangent increases from left to right, and as cotangent is doing what from left to right? Decreasing. There is decreasing from left to right. The range of cotangent is the same as tangent. Your range is still going to be all real numbers because it's going forever to the top and forever to the bottom. So our range is still -infinity to positive infinity. It's only the domain because of the vertical asymptotes that is restricted. Remember, hoi vux, your vertical means that it's affecting your x, right? All right, how do we feel about the graphs? Are we ready to see what types of problems that you may get involving these? Okay. To bring up one from your mock exam, you had one where it gave you, I think, secant x plus cosine x, right? Equal 0, maybe? Can't remember what it equaled. Y equaled y. It was like your last FRQ on the non-calculator part.
That one, it was, yeah, I think it was like, even answer that. You're supposed to transform it to tan and
Yes.
tan and cosine.
Yes.
Or regular sine.
Yes. So what we're leading into is what we're learning in this lesson and next lesson are going to teach you how to solve that. Okay. So now we know that when I see cosecant or secant, I can rewrite them as 1 over sine or 1 over cosine. Also, that's how you would put them in a handheld calculator. In your handheld calculator, you do not have a cosecant, secant, or cotangent button, do you? So in order to put them in the calculator, you have to write them as their reciprocals. So I would write cosecant as 1 over sine in the calculator. I would write secant as 1 over cosine. However, on your, let me double check. I don't want to misquote, but on the, I didn't mean to do that. I want to make sure I go to the right Desmos so that it's accurate. I should have it saved, but at the top, but I don't. So I'm gonna, so that you know the type of Desmo that you're working with for the AP test. Remember, I put the link on your modules page. So if you want to make sure you're using the correct Desmos at all times, it's there. It's right here. Abre. I don't think that they would make it where you would have to use a reciprocal. I'm pretty sure if you're using Desmos, you should be able to write cosecant of x, right? So if you're using Desmos, it will still graph it for you correctly, right? But be mindful, it's the same thing as me writing 1 over sine x. Notice all it did was change colors because they are equivalent. Okay. So if you're in a TI 84, you would have to write it as 1 over sine x. If you're using Desmos, you can clearly just type in cosecant x. Got it? And the same goes for secant. So we have secant x. Secant x, however, is the reciprocal of cosine. Yeah. And then we have cotangent. I can type in COT. Look at those waves. It's the reciprocal of tangent. And it's going to be the same. Okay. So just reaffirming you that you have the tools to be able to graph them. I may have an answer. Hit it.
What we type those stuff on that you know, if there's a way we can put another function to find the sine, cosine functions.
You just, I don't know how to answer your question. It sounds, you just type whatever you're trying to find. Like you just type in whatever equation you're trying to graph, you type it in as it is. Yeah. I think that's what you asked. So I'm going to try it and say that. But maybe if you have a specific example, then I can be like, oh yeah, this is what you're going to do. All right. So here's an example of a question that you may get. It is on the non-calculator part of the test. Okay. So we have here 3 secant 2x, and it says which of the following is a vertical asymptote on the graph of f. Okay. When we are thinking about what this is, we want to think about it in terms of, okay, secant, this means that we have f of x equals 3, and instead of secant, I can replace secant with what? Who's the reciprocal? 1 over cosine. So we're going to replace with 1 over cosine 2x. Okay. The reason why we replace it with that is to remind ourselves that we're asking ourselves, when does cosine equal 0? Does that make sense? When does cosine equal 0? When does cosine equal 0? Meaning, I'm asking when are your x's 0 on your unit circle. So on your unit circle, when do you get 0 values? And typically, and everything is in radians. Y'all remember reading those instructions? Assume in radians. So what radians we would have? Cosine? Yeah. So cosine would be our pi over 2 and our 3 pi over 2. Now, this is if it was a single x. Is it a single x? No. So we need these to equal 2x. That's the extra step. Your inside isn't just x by itself. It's 2x. So this isn't equal to just x, it's equal to 2x. Does that make sense? So if this had just been secant of x, cool. But because it says 2x, I have to identify where it equals 0 and then set it equal to whatever's on the inside. And my inside is 2x. And now I can solve for x. Okay, so solving for x, divided by 2 is the same thing as doing what? Multiplying by a half, right? Dividing by 2 is the same thing as multiplying by a half. So we end up with pi over 4 as an option, and it's there, so I can stop.
Say 2x or 2 on the first graph.
Cosine 2x. Okay. The other option from here would, again, if it didn't say pi over 4 at first, I could come over here. And again, I'm multiplying by a half. And then my other option would have been 3 pi over 4. So either one of these would be where an asymptote exists. Okay. Either one of these in any of their coterminals. Coterminal means I go around and around and around to said values. Well, those are half. We won't put that in depth. It's a little different for trig. For double angles. Okay, are you ready to try it again? Okay, so again, we have to pay attention to what's on the inside of our argument, right? Of our trig argument. Here, we have 4 minus 2 cosecant pi over x. Which of the following is a vertical asymptote of the graph G? Okay, so all of this is great, right? But if I'm looking for the asymptote, I'm looking for what will make me equal to 0 in the denominator, which means that I have to take this guy and rewrite it as a reciprocal. And what is its reciprocal?
4.
So we have 4 minus 2 times 1 over sine pi x. Yes? So now we're asking ourselves, when does y, because sine is y. So we're asking ourselves, when does y equal 0 on our unit circle? At 0 and pi. So we know that this happens when at 0 and it happens at pi. What is the inside of, what is our argument? Our argument is pi x. So we're setting those points equal to pi x. So we set this equal to pi x, and we set this equal to pi x. And both are divided by pi. Both are divided by pi. So we got a possible answer of 0 and a possible answer of 1. Which one is available? The 1. Okay, so when I'm talking about vertical asymptotes, do we understand that's a, well, how is your x affected, right? Vertical go through your x-axis. Yes? Okay, now we're going to talk about the range. How is your range affected? Which means that we're not using x's, we're using the things that change our y values. So here we have h of theta equals 3 cosecant theta divided by 2. Remember, theta just means the same thing as an unknown angle. I have no clue. Did yours print all of your brackets and parentheses? What is going on with the brackets and parentheses? Parenthesis, bracket, bracket, parenthesis. Oh, maybe because they're tight.
Yeah. The brackets, and it's on the bottom of more space.
Oh, maybe. So I should have spread it out more. We'll go with that. Okay. I don't know why they're missing, but anyways, you should have brackets and parentheses there. All right, so it says which of the following gives the range of H? So we're now changing our range. So your range is quote unquote changing for cosecant. For cosecant, our range right now is what? What's the range? It's negative, not for rank, let's go back. For cosecant and secant, what is their range?
-50 to -1,
1 to infinity. Okay. What would have to happen in order for this to change? Would my amplitude change it? My amplitude could change it. My Y could change. I could shuffle, like my midline can change. There's a lot of things to change it. What we're going to focus on is what I'm supposed to tell you to focus on. Can't see my thing. Is our amplitude, because we don't have a midline change right now, right? So our midline is going to be what's affecting it. Okay. Your midline is saying that you're taking your max and your minimum value and you are multiplying them, right? That is a shift to your Y, correct? Your amplitude is a change to your Y. Agreed? No, maybe so. Okay, so what is our amp? 3. Your amp is a direct effect to your Y. Okay, this affects your X, but your amp is going to affect your range, your Y. Okay, so if my previous range is from -1, negative infinity to -1, and then box 1 to infinity, what does amp do to Y values? It amps it up. It amplifies. So that means to each one of these, I'm multiplying by 3. The midline causes it to do what? What is your midline change going to do? It's going to be your vertical shifts up and down. In this case, I am just strictly multiplying. Am I going up or down? No, because there's nothing being added or subtracted to this. Does that make sense? Because there's nothing being added or subtracted. All it is being amplified, being multiplied. Make sense?
X would be or times X?
It's times. I can make it like a fancy times. So we're multiplying. So which one shows the multiplication? It's C. All right, let's talk about cotangent. So for cotangent, we have -5 cotangent 2 pi x. Which of the following is a vertical asymptote? So for cotangent, we're going to start off with writing it as what? What's the reciprocal for that? 1 over tangent. Or it can be written as what? X over what? So cosine x over sine x. So we can write this as -5. And it would be your cosine x, I mean your sine, okay, cosine x. You want to do it this way so you can automatically see what's in your denominator. So what's in our denominator? Sine. Sine is in our denominator. So that's what's going to create my vertical asymptote, right? What's in your denominator creates your vertical asymptote. So since sine is in my denominator, I'm asking myself on the unit circle, when do I get sine equal to 0? So we're looking for when does sine, which is y, equals 0. because that's where your vertical asymptote is going to be. I'm waiting. Someone tell me. Where are my 2 points? 180 and 0. So we have 0 and pi. What is our inside argument? 2 pi x. I did not leave enough space for me to write that. Squiggle, squiggle. And then we have pi equals 2 pi x. I'm going to solve both and see which one is available as an answer choice. So we divide by 2 pi. We divide by 2 pi. This cancels out. This is going to be 0. So we have x equals 0. And what's our other option? 1/2. And which one do we have? 1/2. 1/2 is available. In order to figure out your vertical asymptote, you need to have something in the denominator. Okay? If we did tangent in the denominator, that would have helped us just from the unit circle, right? So that's why we chose, instead of using 1 over tangent, we chose to use cosine over sine. Make sense?
Did we use when the y equals 0? Did we use the sign because it asked for vertical asymptote?
Because it asks for vertical asymptote.
So, are there horizontal asymptotes?
No, we don't have any more. In our inverses, we do, but we don't have any for these. Okay? And hence why the inverses have horizontal, because the opposite of being vertical is horizontal. Okay? How are we feeling about these non-calculator multiple choice type problems?
Doable.
Doable? They're not terrible, right?
I feel like it's deep, but I'm gonna move it.
You're going to forget which part. No, you're not. All right. So solving equations, it's like a whole little thing here. But solving equations involving secant, cosecant, and cotangent. The main thing that you want to do is just rewrite them with sine and cosine. That's good. I'm going to be honest with you. Number one thing is to rewrite them as sine and cosine or tangent when necessary. Okay. So just remembering who goes with who. Does that make sense? So remembering who goes with who so that you can rewrite them as sine and cosine and or tangent. So let's take a look here. It says we have f of x equals 4 cosecant x plus 3 and g of x equals 11. In the xy plane, what are the coordinates of points of intersection of graphs for f and g? Hence, a problem that you had similar to one from your mock exam, right? All right. Exactly. And so very similar. We're going to learn how to solve them, right? Okay. So when this happens, if it says you're looking for your points of intersection, that means that you're setting f of x equals to g of x. Because if they're not equal, are they going to ever intersect? No. If they're not equal, they can't intersect. So now I'm going to substitute in f of x. F of x is 4 cosecant x plus 3. So 4 cosecant x plus 3 equals g of x, which is 11. Okay. Once I've set them equal, I want to get my trig by itself as much as I possibly can. So are there things I can do to get cosecant x by itself? Yes. What can I do to get cosecant x by itself? Subtract 3 and then do what? Then divide by 4. Make sense? So we're left with cosecant x equals 11 minus 3 is 8 divided by 4 is 2. Oh, my ankle. All right. And now we're going to convert this into its sign option. Okay. If I'm going to reciprocate this, I'm also going to reciprocate. So we're now going to write it as a reciprocal.
Oh, I understand.
Does that make sense? We're now going to write as a reciprocal. What is the reciprocal of cosecant? 1 over sine x. And if I have 1 over sine x equal to 2, can I solve for that?
Yes.
Yes. No, you're just reciprocating the cosecant. because these are equal, right? 2 and 1/2 are not replaceable. Those are two totally different things. So I'm going to multiply by sign, and so I multiply by sign. What I do to one side, I do to the other. So now we're left with 1 equals 2 sine x. And then what's the last thing I need to do?
Divide both sides.
Divide both sides by 2. So we have sine x equals 1/2. So you're asking yourself, on the unit circle, when does x equal positive 1/2? Not x. Y'all are going to let me do that and embarrass myself. When does y equal positive 1/2? We're in quadrants 1 and quadrant 2. 16, what else? Not 60. It's 60. Remember the hand? That's 1/2 is.
1/6 or 5.
So we're at the 30s, right? At our 30-degree angles, that's when our sine is 1/2. The sine of 30 is 1/2. And therefore in quadrant 2, what is my other angle? 150. So our angles are x equal, and I'm going to deliberately write them as degrees so that we can convert them to radians. Because a lot of times your brain instantly goes to the degree, but as I read the directions for our test, what does it want us to think about things in? Radians, okay? It also gives you the hint that your answer needs to be in radians because it says from 0 to 2 pi. Do we see that? So if I write in my brain, I'm like 30 degrees. I know that. It's 30 degrees, right? Or 150 degrees. I'm a genius. Cool. You're not going to get full credit. The reason why you're not going to get full credit is because you didn't write it in radians. All you're doing is dividing by 180 and writing pi. Okay? So if you can only instantly think of the degree, divide by 180, reduce, and write your pi. So therefore, my x equals here, pi over 6, and my x equals here, 5 pi over 6. Okay, so radians is a struggle for you. Start with the degree, but remember how to reduce it. This is all non-calculator. I'm sorry.
Cos equals to, like, f of x equals to cos, and if I go from this thing. That's how we know that.
No, not yet, because we have to learn our identities first, which is the next section. But yes, in 3 and 12, we will. Right now, we don't know any identities except reciprocal. We learned one identity. As it's in 3C.11. All right, how we feel? Let's try another one. Let me hide this floating. Okay, so here we have 3 minus 1/2 secant x, and k of x equals 4. And again, it's asking for their intersection because they're asking for their intersection. The only time that something intersects is when they are equal to each other. Okay, so the only time they're going to be intersected is when they're equal. So we have 3 minus 1/2 secant x equals 4. Okay, tell me what I'm doing. What is my first step, friends?
Or multiplying.
I'm going to subtract 3. So we're left with negative 1/2 secant x equals 1. Okay, what's my second step? Multiply by negative 2. And what I do to one side, I do to the other. Good job. So now we're left with secant x equals negative 2. All right. Now what do? We find the reciprocal, right? What is our reciprocal? 1 over cosine x. That's my next step. We'll multiply both sides by cosine x. So now we're left with 1 equals negative 2 cosine x. Perfect. And we divide by -2. Zoom type. So we are ultimately looking for cosine x equal -1/2. So on our unit circle, we're asking ourselves, when does x equal -1/2? So we have to be in quadrant 2, and we have to be in quadrant 3. Does that make sense? Because that's where cosine is negative, that's where x is negative. So in quadrants 2 and 3, thinking of out loud of your unit circle, so it's going to be 120, and what else? 240. So again, our brains naturally feel more comfortable with degrees, correct? So if I assume like, okay, it's at x equal 120, what do I need to tell myself to do? Put it in radians. So I'm going to divide by 180 and reduce that. 120 over 180 reduces to what? 2 pi over 3. So one answer is 2 pi over 3. And then y'all here said 240. I need to put it in terms of radians. In terms of radians, what is that? 4 over 3. Good job. It's your 60-degree reference angles, right? That's when you're going to get the 1/2 for your cosine. Okay?
Wait. Okay, no.
All right. Example number 7 is an example of a calculator one. Okay? So we're going to do it in calculator. I'm going to ask you guys, do you want me to model it in 84 or model it in Desmos? Desmos, okay. Yes. Take the girls fast because you know we don't have a voice. I don't know. I can't blame you or Kelvin. All right. So again, intersection, and it says in what in the XY plane, what are the x coordinates of the points where P of x equals 2? Okay. Because we have this decimal and this decimal, that automatically tells you that this is a calculator problem. Needless to say, I also put a calculator on your notes, but you can clearly see that it's a calculator problem because do those values exist on our unit circle? No, if it doesn't exist. So in the calculator, you're literally just going to two options. Option number 1 is you can create 2 separate equations, like put in the first one, put in the second one, or option number 2 and find the intersection, or put them together and just find where they equal 0. Okay, I will model both and we'll figure out which one you like the most. Cool? All right, so let's go to our handy dandy Desmos. Here she is. All right, so option number 1 is creating 2 separate problems, right? I'm going to change my window so that it's between 0 and 2 pi. To change my window, I come over here to the graph settings. And I need my domain to be from 0. See how you literally type pi, and it will write in pi for you. Okay? So you'll type pi, and it will put in pi. Not 3.14. Type in pi. Okay?
Oh, yeah.
Oh, I forgot the 2. 2. It's your x-axis. It says your x's are between 0 and 2 pi. Is that not what it says? It says in our thing that it's between 0 and 2 pi. What you wanted to count by, if you wanted to count by pi halves, if you wanted to count by pi whatever, right now it's counting by ones. I want it to be something in terms of pi. So I'm going to have it count by pi halves. I'm going to type pi divided by 2. So notice now, these are now half pi marks. Does that make sense? So it's now adjusted its window so that my solids are half. Obviously in between are going to be quarters, right? Half of a quarter. Half is a quarter. So now I have my quadrantals. Do you see that? So we have our 0, our pi over 2, our pi or 3 pi over 2, and our 2 pi. Okay, so I'm going to put in my first equation. My first equation is 3 minus 1 7/10 cotangent half x minus 1.
Yeah, that's the same. And then,
I didn't change the y's. Okay, and then when you put in the second one, when it's just a number, you have to put y equals. Okay, when it's just a number, you have to put y equals. So I'm looking for when y equals 2. And guess what it does? It tells me. It's right there.
So isn't it the force?
It says
The,
the x coordinates of the points. There's only one point between in the interval that it asked us for between 0 and 2 pi. Do you have any other points of intersection? No. So there could be more, but in this case, is there more?
no,
No, there's only one point of intersection.
who would it say? It's, why is it asking for all there?
Because if there was more, they're not going to tell you you only have one. Because technically a line can intersect a trig function in multiple places. Yes. I typed pi divided by 2.
no, I know, but it's actually,
Just for us, like for you to see the values that you can manipulate it to view in friendlier ways. So you can just see your values of your unit circle, right? All right. So we're at 4.1078 radians. Okay, between pi and 3 pi over 2. So in quadrant 3, that's where this is true. Does that make sense? Okay, that's option number 1 is putting it in, making sure you put y equal to 2. Okay, you have to make sure you put y equals to 2. The other option is to make this equal to 2. If you make the first equation equal to 2, all you're going to be looking for is your 0 value. Now, what I've learned about, what's this thing called? Desmos, is that it doesn't find the 0 values like TI-84 would. Does that make sense? So it doesn't always just say, okay, here's your 0 value, and I can't click and like, oh, there it is. Does that make sense? So like it's not allowing for me to quickly find it versus if I did this on the TI-84, I could go from there. But it's not allowing for that to happen, which is why, yes, this is a true statement, but when you're wanting to find your answer, just write it as y equals 2. Cool? Easy peasy. Now notice if I write 2, does it do anything? No. You have to write it as y equals 2 or it will not work. Got it? Yeah? Okay. Now if you want it to work as an intercept, you're going to write it as -2. And it'll work. And that's because you moved it across the equal sign for it. Does that make sense? But if you just write it as equal to 2, then it's going to work. If I write it -2, guess what it did? It moved across the equal sign. So now I only have one argument in my equation. Okay? Yes? How do we feel about 3C11? Doable? Okay. We're going to be masters of multiple choice. Just letting y'all know that.
No, I know.
We are. We're going to be masters of multiple choice.
okay.
All right?